Illustration, missing frequency. If the mean of the following distribution is 26.75, find the missing frequency. Solution. Illustrations, mean. 1. Average wage of 80 male workers is 520 rupees, and average wage of 20 female workers is 420 rupees. Find the average wage of combined group of 100 workers. Solution. 2. The average marks of a group of 20 students in a class is 50. If the whole class has 70 students with average marks of 22.86, find the average marks of the remaining students. Solution. Let the second group as average. 3. An average daily wage of all the 120 workers in a factory is 70 rupees. An average daily wage of male workers is 65 rupees. Calculate an average daily wage of female workers, if 1/3 workers are female. Solution. 4. The average height of 10 students in a class was calculated as 166 centimeters. On verification it was found that one reading was wrongly recorded, as 160 centimeters instead of 150 centimeters. Find the correct mean height. Solution. Merits and demerits of arithmetic mean. Merits of arithmetic mean. It is rigidly defined. It is easy and simple to calculate. It is based on all the observations. It is readily put to algebraic treatment. It is least affected by sampling fluctuations. Demerits of arithmetic mean. It is highly affected by extreme values. It cannot be computed accurately if any item is missing. Arithmetic mean cannot be calculated when open and class intervals are present in the data. Geometric mean. Geometric mean is another type of mean, which is used in many practical cases. In geometric mean we multiply the n number of values, and then take the nth root of the product. Even though the geometric mean is a less commonly used measure of central tendency than arithmetic mean, its t is more accurate than the arithmetic mean for percentage change in positively skewed data. Geometric mean is always less than arithmetic mean, and is calculated only for positive values. Applications. It is used in stock indexes. It is used to calculate the annual return on the portfolio. It is used in finance to find the average growth rates, which are also referred to the compounded annual growth rate. It is also used in studies like cell division and bacterial growth, etc. Geometric mean of ungrouped or raw data. Merits of geometric mean. It is not much affected by the fluctuations of sampling. It is based on all the observations. Demerits of geometric mean. It cannot be easily understood. It is relatively difficult to compute, as it requires some special knowledge of logarithms. It cannot be calculated when any item or value is 0 or negative. Harmonic mean. Harmonic mean is another type of mean, which is used in many practical cases. Harmonic mean is defined as the reciprocal of the arithmetic mean of reciprocals of the observations. Arithmetic mean is appropriate measure of central tendency when the values have the same units, whereas the harmonic mean is appropriate measure of central tendency when the values are the ratios of two variables and have different measures. So, generally harmonic mean is used to calculate the average of ratios or rates. The harmonic mean is best used for fractions such as rates or multiples. Applications. It is used in finance to find average of different rates. It can be used to calculate quantities such as speed. This is because speed is expressed as a ratio of two measuring units such as kilometer per hour. Harmonic mean of ungrouped or raw data, HM equal to, where x1, x2 to xn are n observation of x. Harmonic mean of grouped or raw data, HM equal to, where x1, x2 to xn are n observations of x with frequencies f1 plus f2 to fn respectively and n f1 plus f2 to plus fn. Merits of harmonic mean. It is based on all the observations. It is appropriate measure of central tendency for the data given in ratios and fractions. Demerits of harmonic mean. It can be complex and time-consuming, because it requires using the reciprocals of the numbers in the series. Any extreme values on the high or low end of the series have an intense impact on the results of the harmonic mean. It cannot be calculated when any item or value is zero. Comparison between arithmetic, geometric and harmonic mean. The arithmetic mean is appropriate if the values have the same units, whereas the geometric mean is appropriate if the values have different units, and harmonic mean is appropriate if the data values are in fractions or ratios of two variables with different measures, called rates. Arithmetic mean greater than harmonic mean greater than geometric mean. AM into HM equal to GM square. The harmonic mean necessarily includes all the entries in a series, and it allows a more significant weighting to be given to smaller values. Arithmetic mean can be calculated for a series that includes positive, negative or zero values. Geometric mean can be calculated for a series that includes only positive values. Harmonic mean can be calculated for a series that includes negative values, although it is impossible to compute when the series includes a value of zero. Illustration: geometric and harmonic mean. 1. Find geometric and harmonic mean for the data 2, 3, 4, 5, 6. Solution: 2. The arithmetic mean and geometric mean of two positive integers are 10 and 8. Determine the two numbers. Solution: 3. Find the geometric and harmonic mean for the following data. Solution: Exercise 2. Median and quartiles. Median is another measure of central tendency. Median is the middle value of data or observations. Median is the value of the variable, which divides the data into two equal parts. It is the value of the variable such that the number of observations above it is equal to the number of observations below it. In other words, 50% of the data falls above median and 50% below it. Observations are arranged either in ascending order or descending order of their magnitude. Median is the mid-value of it. Quartiles divide the observations into four equal parts. First, second and third quartiles are denoted by Q1, Q2 and Q3. Median is the second quartile Q2. Mean is the arithmetic average of the data. Median is positional average of the data. Median of ungrouped or raw data. Median equal to n plus 1 by 2 th observation, where x1, x2, to xn, are n observations of x. Median and quartiles of grouped data, if a varied x take values x1, x2, to xn, with corresponding frequencies f1, f2, to fn, respectively, then the median of these values is given by median equal to. Median class is the class in which the corresponding value of less than cumulative frequency just exceeds the value of n by 2. Where L1 equal to lower limit of the median class, L2 equal to upper limit of the median class. F equal to frequency of the median class, CF equal to cumulative frequency of the class preceding the median class, N equal to total frequency. Where L1 equal to lower limit of the Q1 class, L2 equal to upper limit of the Q1 class, F equal to frequency of the Q1 class, CF equal to cumulative frequency of the class preceding the Q1 class, N total frequency. Where L1 equal to lower limit of the Q3 class, L2 equal to upper limit of the Q3 class. F equal to frequency of the Q3 class, CF equal to cumulative frequency of the class preceding the Q3 class, N equal to total frequency. Introduction. Merits of median. It is rigidly defined. It is not affected by extreme values. Even if the extreme values are not known, median can be calculated if the number of items are known. Demerits of median. It is not based on all observations. It is affected by sampling fluctuations. It is not capable of further algebraic treatment. Comparison of mean and median. Mean is the arithmetic average of the data, median is positional average of the data. Mean is defined as the simple average of the given set of values or observations. Median is the middle number in the data. Mean is appropriate for normally distributed data. Median is best when the data distribution is skewed. Mean is highly affected by the extreme value, which is not in the case with a median. Illustration 1, Median and quartiles. 1. Find median of 58, 26, 65, 34, 78, 44, 96. Solution. Arranging the data in ascending order, we have 26, 34, 44, 58, 65, 78, 96. Median equal to th observation equal to 4 th observation equal to 58. 2. Find the median of the daily wages of 10 workers from the following data: 20, 25, 17, 18, 8, 15, 22, 11, 9, 14. Solution. Arranging the wages in ascending order, we have 8, 9, 11, 14, 15, 17, 18, 20, 22, 25. Median equal to th observation equal to 5.5 th observation equal to 15 plus 17 by 2 equal to 16. 3. Find the median and quartiles for the following data. Solution. Total frequency. 54 is first compared just exceeding 40.5. The value of x, corresponding to compare 54 is 40. So, 40 is the median. N by 4 equal to 20.25. 40 is first compared just exceeding 20.25. The value of x, corresponding to CF 40 is 30. So, 30 is the first quartile equal to Q1. 3n by 4 equal to 60.75. 64 is first compared just exceeding 60.75. The value of x, corresponding to compare 60.75 is 50. So, 50 is the third quartile. Illustration 2, Median and quartiles. Find median for the following data. Solution. N by 2 equal to 66 by 2 equal to 33. 50 minus 70 is the median class, since for this class corresponding value of less than cumulative frequency 40 just exceeds the value of n by 2, 33. L1 equal to lower limit of the median class equal to 50. L2 equal to upper limit of the median class equal to 70. F equal to frequency of the median class equal to 23. CF equal to cumulative frequency of the class preceding the median class equal to 17. N equal to total frequency equal to 66. Illustration 3, Median and quartiles. Find median and quartiles for the following data. Solution. N by 2 equal to 96 by 2 equal to 48. 19.5 minus 24.5 is the median class, since for this class corresponding value of less than cumulative frequency 56 just exceeds the value of n by 2, 48. L1 equal to lower limit of the median class equal to 19.5. L2 equal to upper limit of the median class equal to 24.5. F equal to frequency of the median class equal to 24. CF equal to cumulative frequency of the class preceding the median class equal to 32. N equal to total frequency equal to 96. N by 4 equal to 96 by 4 equal to 24. 14.5 minus 19.5 is the Q1 class, since for this class corresponding value of less than cumulative frequency 32 just exceeds the value of n by 4, 24. L1 equal to lower limit of the Q1 class equal to 14.5. L2 equal to upper limit of the Q2 class equal to 19.5. F equal to frequency of the Q1 class equal to 15. F equal to cumulative frequency of the class. Illustration 4, Median and quartiles. Calculate the missing frequency for the following data, if median of the distribution is 170.267. Solution. Since median is 170.267, is the median class. L1 equal to lower limit of the median class equal to 170. L2 equal to upper limit of the median class equal to 174. F equal to frequency of the median class equal to 15. CF equal to cumulative frequency of the class preceding the median class equal to 10 plus A. N equal to total frequency equal to 33 plus A missing frequency is 12. Mode. The most repeated value in a given set of observations is called mode. Mode of a set of numbers is that number, which occurs a greater number of times than any other number in the set. It is the most frequently occurring value. If two or more values occur with equal or nearly equal number of times, then the distribution is said to have two or more modes. In case there are three or more modes, and the distribution or data set is said to be multimodal. Mode of ungrouped or raw data. The value, which occurs maximum number of times in the data is the mode. Mode of grouped data. If a varied x take values x1, x2 to xn, with corresponding frequencies f1, f2 to fn, respectively, then the mode is where L1 equal to lower limit of the modal class, L2 equal to upper limit of the modal class, f1 equal to frequency of the modal class, f0 equal to frequency of the class preceding the modal class, f2 equal to frequency of the class succeeding the modal class. Illustration. Mode. 1. Find mode for the data, 13, 21, 20, 22, 25, 21, 20, 28, 15, 21, 23. Solution. Value 21 occurs maximum number of times, so mode equal to 21. 2. Find mode for the data, solution, since the highest frequency is 30. Corresponding value is 15. So mode equal to 15. 3. Find mode for the data, solution, since the class intervals are inclusive type, they are converted to exclusive type. Highest frequency is 15, so modal class is 29.5 minus 39.5 where L1 equal to lower limit of the modal class equal to 29.5. L2 equal to upper limit of the modal class equal to 39.5. F1 equal to frequency of the modal class equal to 15. F0 equal to frequency of the class preceding the modal class equal to 12. F2 equal to frequency of the class succeeding the modal class equal to 10. 4. If mode of the distribution is 28, find missing frequency. Solution: merits and demerits of mode. Merits of mode. 1. It is easy to calculate and understand. 2. It is not affected much by sampling fluctuations. 3. It is not necessary to know all items. Only the point of maximum concentration is required. Demerits of mode. 1. It is ill-defined as it is not based on all observations. 2. It is not capable of further algebraic treatment. 3. It is not a good representative relationship among mean, media and mode. We have learned about three measures of central value, namely arithmetic mean, median and mode. These three measures are closely connected by the following relations. Mode equal to 3 median minus 2 mean. Or mean minus mode equal to 3 mean minus median. Comparison of mean, median and mode. Mean. Median. Mode. 1. The average of the given observations, which is calculated by adding all the values, and dividing by the number of values, is called arithmetic mean. 1. The midpoint of all the values, which divides the observations into equal parts, is called median. 1. The value, which repeats maximum number of times in the data, or whose frequency is maximum, is called mode. 2. Arithmetic mean is mathematical average. 2. Median is positional average. 2. Mode is positional average. 3. Mean is based on all observations. 3. Median is not based on all the observations, it is the central value. 3. Mode is not based on all the observations, it is the value with highest frequency. 4. Mean is appropriate for normally distributed data. 4. Median is appropriate when the data distribution is skewed. 4. Mode is appropriate when the data distribution is skewed. 5. Mean is highly affected by the extreme values. 5. Median is not much affected by the extreme values. 5. Mode is not affected by the extreme values. 6. Mean can't be calculated for open-end classes. 6. Median can be calculated for open-end classes. 6. Mode can be calculated for open-end classes. Exercise 3. Introduction to dispersion. The value, which reduces the whole data into a single value, and represents the whole data, is called measure of central tendency. Measure of dispersion is another property of a data, which means spread or variation of the data. Measure of dispersion is the degree of variability or the spread out or scatter of the individual items and their deviation from the averages or central tendencies. Characteristics of a good measure of dispersion. It should be rigidly defined. It should be based on all observations. It should be easy to calculate and understand. It should be capable of further algebraic treatment. It should not be affected much by sampling fluctuations. There are two types of measures of dispersion. 1. Absolute measure of dispersion. An absolute measure of dispersion contains the same unit as the original data set. Range. Quartile deviation. Mean deviation. Standard deviation. Absolute relative measure of dispersion. The relative measures of dispersion are used to compare the distribution of two or more data sets. These measures are unit-free. Coefficient of range. Coefficient of quartile deviation. Coefficient of mean deviation. Coefficient of variation. Absolute measure of dispersion. 2. Relative measure of dispersion, range and coefficient of range. Range. It is the simplest absolute measure of dispersion. Range is the difference between the highest and the lowest value of the observations. For group continuous data, range is the difference between the midpoints of the highest class and the lowest class. range equal to maximum minus minimum. Coefficient of range is the ratio of difference between the highest and lowest value of observations to the sum of highest and lowest values. Coefficient of range equal to maximum minus minimum by maximum plus minimum. Applications of range and coefficient of range. Range and coefficient of range are used to measure the spread in quality control, fluctuations in the share prices, in weather forecasts. The meteorological department does make use of the range in determining the difference between the minimum temperature and the maximum temperature. Merits of range. It is easy to understand. It is easy to calculate. Demerits of range. It is not based on all observations. It does not have sampling stability. A single observation may change the value of range. As the amount of data increases, range becomes less satisfactory. Illustration, range and coefficient of range. 1. Find the range and coefficient of range of the following items: 34, 35, 25, 17, 27, 26, 19, 15. Solution, range equal to maximum minus minimum equal to 35 minus 15 equal to 20. Coefficient of range equal to maximum minus minimum by maximum plus minimum equal to 20 by 50 equal to 0.4. 2. Find the range and coefficient of range of the following data. Solution, range equal to max minus minutes equal to 8 minus 1 equal to 7. Coefficient of range equal to max minus minutes by max plus minutes equal to 7 by 9 equal to 0.78, 3. Find the range and coefficient of range of the following data. Solution, range equal to max minus minutes equal to 45 minus 5 equal to 40. Coefficient of range equal to max minus minutes by max plus minutes equal to 40 by 50 equal to 0.8. 4. Let us take two sets of observations. Set A contains the marks of 5 students in mathematics out of 25 marks, and Group B contains marks of the same students in English out of 100 marks. Set A, 10, 15, 18, 20, 20. Set B, 30, 35, 40, 45, 50. Find which group is more consistent based on coefficient of range. Solution. Coefficient of range equal to maximum minus minimum by maximum plus minimum. Coefficient of range of set A equal to 20 minus 10 by 20 plus 10 equal to 10 by 30 equal to 0.33. Coefficient of range equal to 50 minus 30 by 50 plus 30 equal to 20 by 80 equal to 0.25. Since coefficient of range for set B is less than set A is more consistent than set A. Quartile deviation and coefficient of quartile deviation. Quartile deviation is the midpoint of the range between two quartiles. Quartile deviation is defined as QD equal to Q3 minus Q1 by 2, where Q1 equal to first quartile and Q3 equal to third quartile. Coefficient of QD equal to Q3 minus Q1 by Q3 plus Q1. Merits of quartile deviation. 1. It is easy to calculate and understand. 2. It is not affected by extreme values. Demerits of quartile deviation. 1. It is not based on all observations. 2. It is not capable of further algebraic treatment. 3. It is affected by sampling fluctuations. Illustration, quartile deviation. 1. Find the quartile deviation for the following data. Solution. Illustration 2, quartile deviation. Find the quartile deviation and its coefficient and of the following data. Tell me more. Importance of quartile deviation. Like all other measures of dispersion, quartile deviation also measures the spread of the data from the central tendency or average. The importance of quartile deviation is to give an idea about the range within which the central 50% of sample data lies. Mean deviation and coefficient of mean deviation. Mean deviation calculates the average deviation from the average value of a given set of data. Mean deviation of a set of observations of a series is the arithmetic mean of all the deviations. It is the deviations from mean, when calculated considering their absolute values and are averaged. It tells us how far, on average, all values are from the middle. Merits of mean deviation. 1. It is based on all observations. 2. It is easy to understand and also easy to calculate. 3. It is not affected by extreme values. Demerits of mean deviation. 1. Mean deviation ignores algebraic signs, hence it is not capable of further algebraic treatment. 2. It is not very accurate measure of dispersion. Note, mean deviation and its coefficient are used in studying economic problems, such as distribution of income and wealth in a society. Mean deviation on group data. Mean deviation group data. Mean deviation on group data. Mean illustration 1, deviation. Find mean deviation and coefficient of mean deviation from mean from the data, 5, 3, 7, 8, 4, 9. Now, subtract illustration 2, mean deviation. 1. Following data represents number of illustration 3, mean deviation. Calculate the mean deviation from the point 1. Arithmetic standard deviation and coefficient of